Thank you. All right, called your name, and I called your name. Okay. Everybody who's here in real life is now listed. Okay, so the first thing I'm going to do today, and the reason I'm sharing my main screen, is I'm going to walk everybody here through installing and setting up PuTTY, and then installing and setting up CyberDuck. Let me check my online list. Okay, got a few people online already. All right, for my online, or for especially for my online people, but who in this room has already gotten PuTTY and CyberDuck installed and set up? Okay, not too many people. Okay, so everyone at home and everyone in the room, feel free to play along with me because I am just going to get PuTTY installed. So you can get PuTTY from this chiarc.greenend.org.uk site. And PuTTY will come as an MSI. So just run your download real quick. This is just for PC users. If you're on a Mac computer, you can do this directly through the terminal, and I think the cluster administrators even sent you instructions on how to do your SSH. If you're on a Linux computer, anybody here using a Linux computer? Okay, I was guessing you might be, but okay. If you're on a Linux computer, I give you instructions, but you probably already know how to do this anyway. All right, so the MSI is a pretty fast download. Once you get it, just run it. And then do the install. And if you'll probably be prompted for permission or admin. All right, and that's all it takes to really install PuTTY. So I'm going to pop PuTTY open, but I'm not actually going to connect it just yet. So next thing I'm going to do is Google CyberDuck, which I actually happen to remember comes from cyberduck.io. And then I'm going to go to the download link. And I'll have the option to download it for Windows or Mac. So CyberDuck doesn't work in Linux. If you're working in Linux, you're going to need a copy of FileZilla. Just my headset real quick. Oh, FileZilla works very well on Mac. Yeah. No, you won't need CyberDuck if you have FileZilla, especially if you're familiar with FileZilla. I'm just having people use CyberDuck because, especially for trying to demo how to set it up, it's a lot easier. I happen to like the interface better for students. Honestly, it's not even the FTP program I normally use, but for demonstration purposes and setting things up for students, I like it. But if you're on Linux, CyberDuck just doesn't work on Linux. If you're on Mac, CyberDuck will work. If you're on Windows, CyberDuck will work. And I think FileZilla works on all three platforms. I think FileZilla works pretty much everywhere. All right, so I'm on a Windows machine. I'm going to download CyberDuck for Windows. That also tends to be a pretty quick download. And again, you might need admin rights on your computer to install. Can I just get your name real quick for my attendance sheet? Ah, yes. Okay, I remember you now. All right, CyberDuck sometimes takes a minute or two to install. Yes? No, if you have a Mac, the stuff that Putty does, your Mac already does. So yeah, Mac users have no need to download Putty themselves. So if you download it through the Microsoft, if you download it through the Apple Store or through the Microsoft App Store, they will charge you for it. But if you go to cyberduck.io, you can get the free version, which is the version that only asks you to pay but doesn't require it. Okay, so CyberDuck installed. And I'm going to pop CyberDuck open. Okay, CyberDuck I actually already had on here. Okay, does everybody have Putty installed on their computer who needs it? Cool. Okay, so when you first open Putty, you're going to get this little tiny window. And this little tiny window is going to be asking you what it should be connecting to. Everybody have this so far? All right, so the host name is going to be hoffman2.idre.ucla.edu. And the connection type is going to be SSH, which should be the default anyway. Once you've typed that in, you can go ahead and hit open, and I'll give everybody a minute or two to get open hit. All right, I heard a ding. Did somebody hit an issue? Yes? Okay, I'm gonna have a few people get that error. And actually, this is a point where I should tell people, make sure that you're connected to the Collaboratory AP. If you can connect to it, the 5G one, otherwise the 2G. The other Wi-Fis in this room are sometimes a little bit unstable and will have problems. So if you already have a connection, obviously don't switch Wi-Fi. But if you're connected to a different Wi-Fi and your connection drops, switch to the Collaboratory one. As far as the no host found error, that means you probably made a typo when you put in Hoffman. Oh, okay. Yeah. Let's see. No, that's not working. Okay, is that a little easier to read? That's actually fine. That's basically a security warning. The host key is how your computer verifies that it's talking to the real Hoffman cluster. If you ever get that warning at random, if you're trying to connect from a Starbucks, that's a good time to worry about it. In this case, since you're trying to connect from a UCLA network, it shouldn't be as much of a concern. Yes? So for FileZilla, you'll see that you'll basically see the settings in a few minutes when I set up CyberDuck, because it uses the same settings just in a different window. So yeah, FileZilla, you should be able to set up FileZilla as I'm setting up CyberDuck. Collaboratory Wi-Fi is going to be the best Wi-Fi you can get in this room. The router is actually right there next to her. The UCLA Wi-Fi in this room used to be really good, and then about a year, probably about 2 years ago now, they did a bunch of construction around here, and the Wi-Fi suddenly went really bad. In fact, during construction, you actually couldn't get Wi-Fi, you couldn't get campus Wi-Fi in this room at all. All right, is there anybody else who's having trouble getting that connection typed into Hoffman? Okay, so I'm going to then hit open. And you can see I get that same thing about the server's host key is not cached. All right, so you're going to log in as, and your login as is going to be your username. So in my case, that's my username. And then you'll type in your password. As you type in your password, and this is going to be whether you're using a Mac or a PC or Linux, when you type in your password for an SSH session, you won't see anything happen. So you won't see anything happen, and the backspace key actually doesn't work. So if you type in your password and you know you made a typo, the best thing to do is hit enter and then just re-enter it correctly when you get the new prompt. As soon as you get logged in, you should see this thing pop up. You'll get a few notes about the cluster. So you'll get a few important notes. Please do not compute on the login nodes. You'll hear me say that a lot of times. Computing on the login nodes is one of the big sort of etiquette violations on the Hoffman cluster, as it will kind of crap up everybody else's work. Let's see. Oh, and along with that, whatever compute you are running on the login node will be basically just killed by the cluster. Do not pass go, do not collect $200, just killed. Do check out some of these announcements. They will tell you sometimes some cool things. So sometimes they'll have announcements about about a planned cluster outage, because they sometimes have to take down the cluster for maintenance. Occasionally, they'll also post on here about classes. So if you want to get more experience with using some of the more advanced features on the cluster, you can actually sign up for their classes. All right, and people who are connected out there, skip the step I'm about to do. Or actually, no. How many of you have already changed your password for the cluster? How many of you are still using the same password that you got originally? Okay. How many of you think that password is really annoying and you can never remember it? That should be everyone who just had their hand up. Okay, so for those who need it, I'm going to show you how to do a password change. So the command is PASSWD. As soon as you hit enter, it's going to prompt you for your password. So you'll enter the confusing password they just gave you. Once you hit enter, it'll give you some requirements for new passwords, things like length and character requirements. Based on those requirements, you should be able to pick a password that you'll be able to remember a little bit easier. At that point, it'll ask you to enter your new password, and then it'll ask you to confirm your new password. Once you've done that, your password is changed. So sometimes it does take a minute or two to get the password change propagated to all the login nodes. So if you just changed your password, try not to do any logout for about 15 minutes to make sure the password change gets propagated out. That said, I am not actually changing my password, so I'm going to exit out of that by hitting Control-C. All right, and then everybody here who's logged in, stay logged in. I'm going to log out. So don't anybody else run this? Yes? Try going to the IDRE page and doing a password recovery. You may or may not be able to. I think some of the newer accounts, they put in a security question to try and do password recovery. But I don't know if you have it, and I don't know how it works because it's not actually on my account. Okay. Yeah. One way or another, you're going to have to go to idre.ucla.edu. Okay. And then on that page, you should be able to find instructions. So unfortunately, it does have to go through human, which means you're probably going to have trouble. You're probably not going to be able to log into the cluster for the day. All right. So when you get to CyberDuck, everybody have CyberDuck on their computer now? Okay. And I know you have FileZilla, but you should be able to see the settings you're going to need. So once you get into CyberDuck, go to Bookmark and then toggle Bookmarks. So you should be looking at the Bookmarks window. In my case, I already have a bookmark here, and actually you probably noticed I had two others. I got rid of them because I'm just going to recreate them in a moment. You're going to hit the plus button, and I think it's in a slightly different location if you're on a Mac, but you should still see a plus button to create a bookmark. And that's going to pop up with this window. So the nickname for this one is going to be Hoffman2Home. The username is going to be your username. So obviously your username is going to be different than mine. The server is going to be dtn2.hoffman2.idre.ucla.edu. And yes, I will write that out here. Otherwise, a lot of the default settings should be fine. Yes? Cluster. Yeah, everything we do is going to be with a cluster username and password, not the grid username and password. Okay, so when you start off, you should see a screen like this actually, and you can put your username here, the server name here. You'll also hit more options. So in this case, we're not going to change anything down here, but in a moment we are. So once you've done that, you can close this down. And you should have a new bookmark called Hoffman to Home. So in my case, it wasn't asking for my password because my password is frankly already stored on here. You also won't see a long list of stuff on there because I have a bunch of crap in my home folder that you probably don't. Yes? Yeah, it looks like it should work. Mm-hmm. All right. Go to create bookmark. Sorry, I can't navigate yours. I don't speak that language. Oh no, go back to CyberDuck. Yeah. Go to bookmarks. Yeah. I think it uses whatever language your computer is using. So I'm guessing your computer is set up in is it Chinese or? Yeah. No problem. You're just gonna have to sort of guide me a little bit. Try going to the top one. Okay, hit the plus at the bottom. Nope, not there, not there. Get out of that menu, hit the plus. Okay, so actually this is what you need to change. You need to change that FTP to SFTP. What? Yeah, SFTP is how you connect to Hoffman for transferring files. Username. All right, and hit the exit. Hit the X at the top. The exit button. Nope, not that one. Yes, hit that. Okay, now double click that link. Yeah, so say yes. Okay, now it's going to want that password. No, I said login failed. I don't know why. So, is this that password there? When was it created? Last year. Oh, that's not. And you changed it since then? So last year I have a temporary one, and this year I tried got a new one. Okay, but that's your original password? I think it changed the temporary one. Because I just recently requested because I forgot the last one. So That's the new temporary one they gave you?
Yeah.
When did they give you that one?
Probably a week ago.
Weeks ago?
Yeah.
I think the temporary one may not still work. I don't know if the temporary ones have a limited lifetime.
Oh, really?
But did you already log in once with that one or anything?
No.
Yeah, I'm wondering okay, so that one I think should work unless it's expired. So yeah, you probably need to contact them to get your password changed.
Okay, cool.
Because assuming you're typing it right, that should get you logged in.
Okay.
All right. Was everybody else able to get connected? No? Okay. Let's have a look. Sorry. Okay, so the first thing you're going to want to change is the top part where it says FTP, and you'll change that to SFTP. So you have a typo. So first thing is before Hoffman 2, put DTN2. Before Hoffman 2. Yeah, there you go. All right, then you should be able to put in your username and password, and that should get you connected. All right, how are you doing? SFTP. Bottom, there you go. Yes. SFTP.
Oh, yeah, I'm in already.
Oh, okay,
yeah,
cool.
Yeah.
Oh, okay. So I'm going to go into what DTN2 means in a minute. Yes, put DTN2 dot before the Hoffman 2. It's sort of an etiquette thing on the cluster, and I'll explain why in a minute. All right, who else is having trouble getting connected? Okay, got a couple more. All right, you getting an error message? Yep. Oh, DTN2, not DTM2. Yep, that is what you want to see. So hit always allow. Okay. It should give you the option to remember your username and password. There you go. Oh, okay. All right. Who's still having trouble getting connected?
Oh, I'm not sure what you mean by connected.
So if you double click that bookmark, what happens? Oh, hit allow. So yeah, username on the top, and then password. Although it has your username.
Yeah.
Okay, cool. So the RSA key is basically a fingerprint for the server. Because when you think about it, if you're typing that in and somebody on your network is basically being a jerk and trying to claim that they're the Hoffman cluster, they're basically trying to intercept your connection. So on a network like here, where it's controlled by UCLA, it's pretty reliable. You know the router is right over there, and you're assuming that I'm not doing anything bad. That's a good time to accept the server fingerprint, or like on your home Wi-Fi, probably pretty reliable. The time to worry is if that fingerprint changes, but they haven't announced any service on the cluster. That's a time to be concerned. And especially if you're connecting at like a Starbucks Wi-Fi where you don't really even know what the router is, and you see the server fingerprint suddenly change, that means somebody could be trying to mess with your connection. But there is a point where you need to check the server's fingerprint, and this is a good one. Okay, so I had a few people asking what the DTN2 means. And if you try and connect through hoffman2.idre.ucla.edu, it will work, but it's kind of an etiquette thing on the cluster. So when you connect to the cluster, I think everybody should still have an SSH going, right? Can somebody read me what their command prompt says? So it's going to, it'll be your username at login. And in her case, it's 4, but I'm guessing some people have 1, 2, or 3. So what that's actually telling you is it's telling you your username. It's telling you what node you're actually connected to. So right now, you're connected to a login node, and there's 4 login nodes. The login nodes are just for basically connecting SSH sessions and forwarding SSH sessions to other nodes, specifically compute nodes. The login nodes generally should not be used for moving large amounts of data across. Does anybody know what the purpose of CyberDuck is? Moving large amounts of data across a server. So that's what the DTNs are for. So they have DTN2, and I think DTN1 is back online. I know at one point I wasn't able to connect to it, which is why I'm on DTN2. But the DTN stands for data transfer nodes. Those nodes have faster internet connections. And those nodes are designed specifically for moving data on and off the cluster at higher speed and also without disrupting anybody else's connection. So the times to use data transfer nodes are, number one, if you're connecting through FTP or through SFTP. That's kind of what they were meant for. But also, if you want to download a very large file from the internet to your cluster account. So for example, if you want to transfer a copy of the human genome onto your account, which is a pretty common operation, you typically want to connect through a data transfer node and make that transfer. You don't want to just do it through your compute node or through your login node. It'll go much faster, and it doesn't risk degrading anybody's connection. All right, so the next thing we're going to do, now that we've done that, is we're going to go and create another bookmark. And the nice thing about CyberDuck is it'll start off your next bookmark with your previous bookmark. So everybody should have something that looks like this, with the few exceptions that it's going to be your username, and this path here is going to be /u/home/ the first letter of your username / your username. If you don't have this bottom part of the window, click the More Options over here. Is there anybody who doesn't see that? There we go. All right, so again, you should have the exact same settings as before. This should say Hoffman Home. We're going to change this in a minute. This should say still the same server, Hoffman, dtn2.hoffman2.idre.ucla.edu. This should still be your username. We're not going to change that. If you don't have this part down here, click on More Options and it'll pop up. For path, you should see /u/home/ the first letter of your username / your username. Is there anybody who doesn't see that? Okay, good. So the nice thing is we can make our next bookmark from our last bookmark. So we're going to do two things to make our next bookmark. We're going to change the word home to scratch. And in the path, we're going to get rid of the word home. Make sure you keep the slashes on either side of it. But we're going to get rid of the word home, and we're going to change that to /scratch. All one word. You can see it over here. And then I believe once you've made those 2 changes, you should be able to close that out. Double click the link, and you'll discover that it still remembers your old password. So the only 2 things you should have to change, you'll change the nickname. Yeah, in nickname, you're going to change the word home to the name Scratch. Oh, and 2 side notes. If you're using one of the Collaboratory computers, obviously don't tell it to save your password because that's not your computer. And for the people who are joining us out there in WebEx land, looks like we've got a few more people. Please do remember to keep your mics muted. I don't think anybody has been talking over me this time, but definitely before we had an issue with somebody not having their mic muted and picking up a lot of background noise. So the Flash Scratch, if you go down to path, you see the word home as part of the path between 2 slashes. Replace the word home with Flash Scratch. So make sure the 2 slashes on either side stay there, but replace the word home with Flash Scratch. Yes? That's fine. Allow. Hit allow and actually hit always allow if you have the option. All right. Is there anybody who wasn't able to get the second bookmark connected? Yes? So when you make the Hoffman 2 home bookmark, if you don't put in a path, it'll automatically fill it for you. That's actually one of the cool things about doing it this way is you create the home bookmark and then you connect to it. And then when you go to create the Scratch bookmark, the path has already been filled in for you, and you just have to change one part of the path. Yes? Let's have a look. So you're going to change the nickname, and yeah, you changed the path already. So let's change the nickname, and then you should be set. You're gonna change that nickname to from where it says home. You're gonna change it to Scratch.
So these are the 2 things I should be having.
Yeah. So double click on the Hoffman 2 Scratch. Yep, that's what you should see because you don't have anything in your folder. So okay, so you are connected. Yes. All right, so double click there. Hit always and allow. Oh, set your computer down for a second. Set your computer down. All right, so you just have a little mistake in there, I think. Let's cancel out of that. All right, so the username is actually not all that. The username is just your username. And then leave that blank for now. Okay, it connected. All right, so the next thing we're going to do is I'm going to disconnect that, pop your bookmarks, create a new bookmark. So the first thing I'm going to do is in the nickname, I'm going to change home to Scratch. Next thing is here where it says home, I'm going to change that to Flash Scratch. And that takes you directly into your Scratch folder on the cluster. There you go. All right, anybody else not able to connect their bookmarks? Yes? So you should, so first try and get the home connected. If you can't get the home connected, you won't get the Scratch connected. Looks good to me. Close that window and double click on the link. Hit always, or actually no. Actually, you can hit always allow on that. That's fine. All right.
I should check it once I submitted my account if I got
Yeah, check and make sure your account's approved. So did you get a temporary password?
No, I didn't.
Okay. What password are you trying to use on there?
I used the one because I made the account, and then it's like, oh, then.
Oh, you're trying to use your UCLA logon password?
No, I have my own UCLA login. Yesterday when I created my account for the Hoffman account, then I've been created, but I think they still have to go through approval.
Okay, so you're waiting on Hoffman account approval.
Yeah.
Okay.
So should we just check if the Hoffman account?
Yeah, keep an eye on your email for Hoffman account approval.
Okay.
What password are you trying to put in there?
The one that I use the one that I inputted for my account that I want to use.
Oh, okay. Yeah, that password's not going to work. Yeah, they're gonna send you an email and it'll have a link to a temporary password. So the temporary password's the one you're going to want to use.
Thank you.
Okay. Everybody else, have you managed to get both your SSH going and your CyberDuck going? Okay, cool. All right. It's 9:52. I'm going to get my screen actually reset for sharing PowerPoint because I need to do some video changes. Now would be a really good chance. Anybody who needs to use the restroom or get water or stretch or anything like that, let's be back at 10 a.m. sharp. Again, for those who need to know, women's restrooms are behind the elevator that way. Men's restrooms are also behind the elevators, one floor up or one floor down. And for those who are still here, if you have any questions, I will be around to answer. I'm just going to be setting up a screen. Yes, the PowerPoint should already be online. If they haven't been sent out as a link, let me know. And actually, the talk from yesterday is on, I just posted on YouTube yesterday. So as soon as I'm done with this, I can go over and pull it up on your computer. Okay. Oh, sorry. I can answer now.
My bookmarks don't appear. Well, the two bookmarks that you added is great.
Try closing that down. Oh, hit bookmark up at the top. Hit toggle bookmarks.
Oh,
There you go.
all right. Thanks.
No problem. That's an easy one. All right. For anybody who is still here, I think most people are still here. A few people are out. No, there's actually a video of the WebEx already uploaded. It should be on YouTube. I can track it down in just a moment. All right. Let me actually let me borrow this for a second. Oh, did you draw that or?
No.
Oh, okay.
Do you mind if I come up tomorrow a little bit early to like confirm with all the setup because I don't have it off now. I'll probably try to do it myself tonight. And if I
Yeah, no problem.
Yeah, I'll just come here and ask.
Okay, there you go.
Oh.
So yeah, that should look familiar from yesterday. All right. Who else is looking for the copy of yesterday's video? Ah, let me get it pulled up on your computer too. I'm gonna sneak behind you. Sorry. All right, go to YouTube. Cool. Let me borrow this for a second. Mm-hmm. What's up? Oh, yeah, I can pull it up for you. So it will be
Trying
sort of.
to Google your email, YouTube, your name. I was like, can you type under your name?
There you go.
Thank you so much.
Mm-hmm. All right, so I think everybody should be back. All right, so everybody should have a login session going with the Hoffman cluster. I know some of you don't have passwords that are active yet. Hopefully those work soon. So you should just have a command prompt right now in your home folder. You should be seeing your username at login and then some number. So I'm going to need you to run a couple commands really quickly. And these commands, you'll run both of these, and both of these you're going to wait a little while on. So the first command you're going to run, there we go, is QRSH. So you'll do QRSH. That's actually taking you from a login node to a compute node. So compute nodes you can run heavy-duty computing jobs on because that is your node. We're not setting any options with this one, so we're just going to get a default power compute node, which is basically 1 core and a couple of gigs of RAM. But that's really all we're going to need. So your first command is going to be QRSH. You're going to hit enter. You're probably going to see some warning that says JSV did not specify blah, 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 blah. You can pretty much ignore that. That's actually just a warning saying you didn't set any options, so you're getting the default settings. You're then going to see absolutely nothing happen after that, including you're not going to get back your command prompt. That's perfectly fine. It's going to take a few minutes for you to get back your command prompt. When you get back your command prompt, you're going to see that your command prompt has changed a little bit. It's now your username at, and then probably N, and then some 4-digit number. Did some people already get compute nodes? You guys already got compute nodes? Okay, I owe the cluster maintenance people some beer then, because I think with their last maintenance, they must have really improved the scheduling system. It used to be people would type in QRSH, and I basically say you got to wait about 5 minutes for your interactive session to start. But it sounds like people's interactive sessions are now starting within a few seconds. Ooh, okay, that actually improves the timing of this class a lot. And then the other nice thing is I think they also improved the performance of the storage system. So the next step, I'm curious to see how long it takes as well, because the next step also used to take several minutes. So the next step is once you get your interactive session going, so you get back your command prompt on N you know, and then probably some 4-digit number. So for people who know command line, what does this do? Copy. What is this kind of pointing to? Can anybody describe what I'm probably pointing to here? What? I'm pointing to my flash directory, or my, I'm pointing to my Scratch folder. I'm pointing specifically to this file. Just from the name, what can you probably tell? What kind of stuff can you tell me about this file? What? It's compressed. What else can you tell me about this file? What? I heard somebody say it. Okay, so you know it's a tar file. You don't know what a tar file is. Okay. Tar. So .tar. I think people call them tarballs. It's a Linux folder. It's basically a whole directory structure in Linux that's been put into one file. So yeah, tar actually stands for tape archive. It's a program that was originally started in the 70s, and you would actually run tar on your entire file system to save it to a tape backup, back when, you know, they did tape backups. So obviously we're not doing tape backups anymore, but it turns out tar still proved itself really useful for taking an entire directory structure and moving it into a single file. And if you do tar.gz, that just means it's a whole directory structure moved into one file and compressed down. And can anybody guess what this means? The answer should be pretty obvious. Workshop 2. So this is basically a directory structure for all the Workshop 2 stuff that is compressed down and put into a single file. So how does a copy command usually go? You have copy, and then what do we usually call this part? What? So you call it a path, but specifically, what's the path for? So this is the source, and this part will be the destination. So this $ capital letter scratch, does anybody know what that usually means, especially on a command line? A what? A variable. So on everybody's account, you may not know this, there's a variable automatically set for you that is $scratch. That represents your Scratch folder path. So no matter what your username is, this will represent your Scratch folder. So what the command here is essentially copy the Workshop 2 data from my Scratch folder to your Scratch folder. So who's already running this? Is it still going? Okay. About how long did it take for you? Okay, that is way better than it used to be. All right, so I'm going to let everybody let that go. If you run it and you don't get a command prompt back, that means it's probably running. If you run it and you immediately get back some kind of a weird error message, throw up a hand and I'll probably ask you to read off the error message so we can diagnose it. So you're going to see this more and more is, especially as we get into examples, I don't make you read off your error messages to embarrass you. Nobody should be embarrassed about getting error messages. Getting error messages is part of doing work. I make you read off your error messages because chances are, if you get it now, somebody else is going to get it in 10 minutes. And if I make you read it off and walk the class through kind of diagnosing the issue, then that somebody is going to be able to fix it themselves. In my case, well, yeah, you actually do. So the Scratch folder, my Scratch folder in my case, that file has permission for other people to copy. But yeah, generally don't put anything confidential in your Scratch folder, and actually don't really put too much confidential stuff on the Hoffman cluster. I don't know what its status is as far as Department of Medicine for patient information. That's something you'd have to check with them. But just general, don't put highly confidential stuff on the Hoffman cluster. And if you have to put something on there that has to be kept secret, keep it in your home folder. No. So your home directory does not contain your Scratch. Your Scratch is probably on a physically different machine. Okay. Sorry, I'm doing a real quick check on the chat feature in WebEx just to see if there's any comments. It looks like there was one question, but it's already been taken care of. Was everybody able to get the transfer to work? Is there anybody whose transfer is still going? Okay, so there's still a transfer going or two. I'm going to give it another minute, and I'm actually going to check email super fast just to see if there's any course-related questions. All right, be just 1 second. I'm responding to a student question online. Okay, so I think everybody's gotten the transfer completed. Sorry for the delay there. I was answering a student question online. Apparently, Hoffman cluster password issues are not just limited to the room. There's also somebody else out there having one. All right, so everybody went through this. I should be able to close it down now. Is there anybody who still needs these directions? Okay, cool. All right. Apparently, I need to go ahead and restructure this part of the class. I actually used to have this structured around that operation taking several minutes. And I used to actually go over a section of slides during that, but apparently now it's a lot faster. Your transfer's still going? That's impressive. You are on EduRoam, and okay, I see what is likely the problem. I'm going to end up killing your session by doing this, so you'll have to get a new one. Okay, yeah. So in your case, it wasn't that the transfer was taking a long time. It was actually that the
And it wouldn't just tell me that I'm like kicked off the node or anything like that. Because I thought it happened before to like drop off a message.
So a lot of times it'll just drop you off until your connection has been terminated. But that's kind of if either party disconnects, then it'll usually generate that. Or if it disconnects because of some error, it'll generate that. If it disconnects because the internet connection is spotty, sometimes you won't get that. Sometimes it'll just be like, hey, I'm waiting for a new message. Well, especially if you're in the middle of running something, it'll be like, okay, I'm just here waiting for somebody to say the job's done, and nobody's saying the job's done, and what it doesn't realize is the other system's not connected. So, oof, yeah, that is dead. Yeah, see, like in this case, I gave it a command to stop. I even changed your Wi-Fi connection to a new access point, and it still doesn't realize that there's no connection. There you go. So that's actually that socket connect wait thing, that error message you see. That's basically it saying it was waiting for some kind of response, and it just timed out eventually. But it never actually got a proper. It's basically like, if you ever want to really mess with telemarketers that are getting on your nerves, get them to launch into their sales pitch and stick your phone in your pocket. And that's basically what happened with her connection. Yeah, you're going to SSH in again.
Oh, I'm not even. Oh.
Yeah, you're actually disconnected. So, yeah, so in your case, you were actually on the EduRoam network.
Yeah.
So if you notice that your connection goes out, check your Wi-Fi. Make sure that you're on Collaboratory AP. EduRoam in this room, it'll occasionally drop out, and you'll run into situations like hers where your SSH connection will basically just hang, and it doesn't even look like it failed. It just looks like it's not responsive anymore. It's really annoying. All right, as soon as you get your SSH going, I'm going to steal your computer from you just so I can get you caught up.
Yeah, I'm requesting a retreat access session, so let's do that.
Okay, well, I think they're going quickly now. But yeah, a lot of network connections are based on the idea of getting like a hang-up signal. So your SSH connection will close properly if you get a signal saying, if the Hoffman cluster says end the connection, your connection will end properly and you'll get back a command prompt. If your computer, if you type log out, your computer will send a message to the Hoffman cluster saying, okay, I'm done with the session, and everybody's happy. If your internet connection suddenly becomes spotty or drops out or starts like randomly losing messages, then the hang-up signal may actually get lost. And it's basically like you have the telemarketer on the line going into their sales pitch, and you put your phone in your pocket. They're going to be there for a good solid minute saying, hello, hello. Okay. There you go. So once that's done, you're caught up. Yes.
I'm not finding the file at the top.
Which folder are you in right now?
I'm in.
So read me your command prompt.
Oh, it says James and 4034.
Okay. Okay, so the tilde is actually something important. So his command prompt is James N at N4034 and then the tilde. So it's his username. Now he's on compute node 4034. You're generally not going to care what compute node you're on, with one exception. Occasionally you get on a compute node that's busted. I've done that before. They occasionally have a compute node that gets bad routing instructions, and you try and get it to pull some resource off the internet, and it just can't connect to the internet. In that case, you do want to record which compute node you're on because you want to notify the cluster administrators, because they can actually send it new instructions, and they can basically fix it. The tilde is actually the directory you're in. So who here knows what the tilde means on the command line? Yeah, it's your home folder. So the tilde actually means you're in your home folder. So the reason you're not seeing what you got is the stuff that you copied from my folder. Where did you copy it to? Yes, so you copied it to your Scratch folder. So what would be the command to get you to your Scratch folder? So it would be CD is change directory, right? And then space, and actually everybody should do this too. So CD and then space, and then $Scratch with Scratch all in capital letters. Okay, you're caught up? Cool. If there's patient, yeah, for PHI stuff, you're going to have to actually defer to the Department of Medicine people. I don't know what their policy is with regard to the Hoffman cluster. If there's PHI, I'm pretty sure it doesn't belong in the Scratch folder, but I'm not even sure if the home folder is approved for that. I know they're liking people going on to AWS, but even AWS uses a shared responsibility model where it's like, we have secure configurations, it's your responsibility to actually put them in place. And a lot of people don't put them in place right, and then AWS is like, well, that's your fault, you didn't set it up correctly. It should go in Scratch folder while you're working with it. Don't keep too much stuff in Scratch folder if you're not working with it, because they have limited space on that drive. So basically anything in Scratch folder, if you haven't touched it for about a week, it can be suddenly deleted. Yeah, anything that has a last use date that's over a week old is subject to deletion. Okay, so while you're working with it on the cluster, you can definitely store it in your Scratch folder. That's what it's for. If you're talking about long-term storage, like for your notebooks and to save it for submitting journal articles and grants and that kind of thing, there isn't really a centralized place for doing that. Department of Medicine might have some kind of resource in that area. I can't guarantee they do, and I suspect they probably don't. In that area, you're probably either looking at buying some external hard drives for your lab, so one to keep a copy and one to make a backup. The core service you use may or may not save copies for you. And another alternative is actually using Amazon Web Services and just paying them for some storage on there. Yeah, if you want to give me a call later, I can actually walk you through some of the storage options for these things that are probably that are hopefully not going to run afoul of the Department of Medicine. Okay, so I can pick this right back up. All right, so the Hoffman cluster has software already installed on it. for a lot of uses. For a lot of other software, you can generally install it yourself. I'm actually going to walk you through a little bit later how to install some of your own software on there. Or not your own software, but some software you download. So, and I should mention, this /u/local/apps, you can see a list of all the software that's already installed on the cluster and ready to run. If you find yourself wanting to run software that's not on there, and a little bit later we're going to run a program called FastQC that doesn't exist on the cluster. When we run that, I'm going to show you how to basically download a copy of it directly to the cluster, install it, and run it without having to go through the administrators. There's actually very few things that require administrator rights to install in the cluster. So if you want to run something that requires admin rights, you have to go through the administrators to get approval. They will probably say no. And they will probably say no, and they'll probably tell you that there's a way to run it without having administrator rights. They generally don't want you running anything that requires administrator rights because that means that if your software goes haywire, it can start doing some serious damage. Okay, so I think I walked everybody through this. Everybody had a login, so I can actually skip over this. All right, brief intro to computer languages. So I know some people here have programmed before, some people haven't. So C language or C++, quick show of hands, who's programming in those languages before? Okay, a couple people. Who's done like extensive work in C or C++? Okay. Yeah, so a lot of people have written like a few programs, like a Hello World or two, and and maybe like maybe a program that takes in your name and says hello your name. But yeah, so you've written some more complicated stuff in those languages. Yeah, that's pretty common. C and C++ aren't super popular anymore in the bioinformatics world. To a good extent, they never were super popular, except for some of the hardcore programmers. So Java, who here has done any extensive work in Java? Okay, yeah, that's nobody. Java's fallen out of favor. I don't blame them. Java had so C and C++, those are compiled languages. So you write human readable code, somewhat less readable than other languages, but still readable. It gets compiled down to machine language, and then the machine runs basically something that's already written in machine language. The data structures in there aren't always that flexible, but it has the advantage of being really performant. Programs written in C and C++ tend to be well, not even super fast anymore, but they tend to be faster than the same program written in another language. So Java, also a compiled language. They got the idea to basically you compile the language, and every platform has what's called a Java virtual machine that'll basically run compiled Java programs. They did this because they liked the idea of if you compile a Java program on a Linux machine, the compiled version will still run on a Windows machine or a Mac, as long as it has a Java environment. So their idea was compile once, run it everywhere. Turns out the reality was more along the lines of compile once, debug everywhere. Get frustrated in many, many places. So there's very little bioinformatics software now that, well, there's some bioinformatics software that's written in Java, but most new bioinformatics software is not. Perl. I know there's at least a couple Perl programmers in the room. Who here has written a decent amount of stuff in Perl? Okay. I actually started off programming in Perl. I moved over to Python. Perl is kind of it's a language that has a lot of tolerance for slop. Perl is not a compiled language. So there's actually an interpreter that runs and goes over your Perl script and executes the commands in the Perl script. And Python. Who here has done some programming in Python? Okay, quite a decent number. Python has kind of become the standard language for bioinformatics. pretty much if somebody's writing a bioinformatics app, they're probably writing it in Python. If they're not writing in Python, they're probably an R programmer, and they're probably writing it in R language. So Python has kind of solved a lot of the issues. It's fairly easy to get started in. It's fairly easy to program in. It's an interpreted language, so you have an interpreter running, so there is some overhead that'll kind of take a little bit of performance away. But the Python interpreter is so commonly used now that a lot of people are applying all these really neat hacks to make it very performant. I've actually seen it do some really neat tricks to get performance that is just a little bit slower than something written in C. And actually parts of Python are even written in C, or Python extensions are written in C so that you get basically C language performance. Python has code blocks. It has blocks of code denoted by indentation. So in other languages, you usually have the curly braces. In Python, you just have your indentation that tells it where different blocks of code are. This is really good because people are supposed to indent their blocks of code. If they get lazy about indenting their blocks of code in other languages, the language doesn't really care, but people trying to view their code do. In Python, if you don't indent properly, the program does not work. Python gives very explicit error messages, and Python doesn't try and do a lot of things implicitly. So with Python, you'll always get to see the source code. Python tends to be a lot cleaner, so you'll be able to understand the source code. And the reason I'm talking in detail about Python is the Collaboratory, if you want to learn how to write your own programs in Python, the Collaboratory will support you. There's Python classes available. Has anybody here taken our Python class? Yeah, okay, so I know you took it. So yeah, we have multiple Python classes. We have an intro. We have an advanced Python, which is actually going on in the afternoon. We also have Python for machine learning, and we have Python for image analysis. And I don't know if we had any more Python, but basically we started off with just an intro to Python class, and the most common review we got on that class was, we need more Python classes. All right, so again, when you log into the cluster, you're going to see just a few things. As I mentioned, when you type in your password, you won't see anything happen. You won't see little dots appear or anything. It's just sending off your keystrokes to the cluster. The backspace key will not work. So if you know you made a mistake or you think you made a mistake, best thing to do is just hit enter and enter the password correctly on your second attempt. Do not compute on login nodes. I'm going to say this a lot of times because people will occasionally make this mistake. In fact, a lot of times before I start a major compute job, I will check my command prompt just to make sure that I didn't lose an interactive session and get kicked back to a compute node or to a login node. All right, you'll also see that there's some announcements here. Obviously, these announcements are dated 2016, so these announcements aren't going to be current. Do keep an eye on those announcements. A lot of times they'll cover some additional classes you can take to learn how to use a cluster, or they'll tell you about a planned cluster outage, and then you'll get your command prompt. So walked everybody through this. There's two ways to run a job on the cluster. One of them is what you've already done. Do QRSH to get yourself an interactive session and run the job interactively on a compute node. That works pretty well for shorter jobs or jobs where you have to sort of keep an eye on it and interact with it while it's running. If you want to run an 8-hour job, what happens if you lose your connection when you're on a compute node? Your job dies. So the way you deal with that is there's also a way to run jobs on the cluster on the queue. I don't really teach that in this class, but if you need a hand with it, I can point you to some good documentation. Basically, the idea of running jobs on the queue is you submit the job, you don't need any connection to the cluster, the job just goes into a job queue, and as soon as the cluster has the resources available and it's your turn in line, your job will get run. You don't need to interact with it at all. The only interaction you'll end up needing with it is if you tell it to send you emails, it'll send you emails when it starts. It'll send you an email if it aborts in the middle, and it'll send you an email when it finishes. All right, there's a few other options you can do with QRSH. So you can, for example, set some specific limits. So in this case, it's setting the memory as 3 gigs. This is using the high priority queue. The high priority queue is what you get to use if your department or if your PI owns resources on a cluster. specifically if your PI owns some of the compute nodes. So if your PI owns compute nodes on there, and you set high priority, it'll run the job specifically on your nodes. That has the advantage that you can use that node instead of for a 24-hour max job, you can use that node for a 2-week job. Has the disadvantage that you may have to wait up to 24 hours to get your node back, assuming that you'll have to wait more than 24 hours if you have other high priority jobs on your node. If other users are using your node because you weren't, you might have to wait 24 hours for them to finish their jobs. In addition to that, you may have to wait 24 hours to get your own node, and sometimes it's really not faster to do it that way. If your job is going to take less than 24 hours, you're probably better just submitting it to the general nodes. And if you put high priority and your group and the account doesn't have access to any private nodes or any lab-owned nodes, your job will sit in the queue forever. It will sit there literally waiting for nodes that don't exist, and it will sit there in a waiting status eternally. All right, I've already gone over CyberDuck in detail, so I don't need to go over that anymore. All right, so enough theory, let's start getting into how we're actually going to do stuff. Sequencing file formats. What do you get back when you get read analysis? So it turns out that sometimes the file names can tell you stuff. If you get back your data already cleaned up from the core, you're probably not going to see any of this. This is a lot of stuff that's under the hood. So this 3 will tell you there we go. This will tell you the lane you were in. This will tell you the redirection, so 1 for paired N1, 2 for paired N2. This will tell you your tile number, which is basically the part of the lane. And this is QSeq format, text data, and gzipped. Who here has gotten back FastQ data? Or who here has seen FastQ? Okay, a couple people. Who here has seen QSeq data? Okay, this is actually basically, this is tale as old as time in bioinformatics and computing. I had a problem. I decided that I needed to come up with a new format to fix the problem. I now have 2 problems. QSeq is a format that people were using for exchanging raw sequencing data. FastQ is a format people use for exchanging raw sequencing data. These 2 formats basically had it out and sort of fought probably about a decade ago now. They fought it out a while ago. So when I asked who's seen FastQ data, a few hands went up. When I asked who's seen QSeq data, nobody's hands went up. That's because nobody uses QSeq anymore, with the exception of 1 core on campus. Anybody here using the Broad stem cell sequencing core? Nobody's using them? Okay. That's why nobody said they get QSeq. The Broad stem cell sequencing core, last time I checked, was in the habit of giving people QSeq data. I'm really embarrassed to say the reason for this is they built up a pipeline around QSeq. The person who runs that core has the attitude that QSeq was actually the right choice in the file format wars. And because it's his core, he's decided that everybody else is wrong and you will get back your data in QSeq format. And you're the one who's in the wrong for trying to change it into FastQ, even though every program now that handles raw sequence data expects the data to come in FastQ formatted. If you think this is bad, wait until I get to quality score encoding. Yes? Is a lot a valid answer? I know there's like the neuro one in there's the neuro one in Ganda. There's the Broad stem cell core one in Terasaki. There's the microarray and sequencing core. I think I don't know if it's still there, but there was a genotyping and sequencing core that was associated with human genetics. And I think there's a few others that I can't think of off the top of my head. But I'd say we're at least 4 or 5, and those are just the ones that I've known about. There's probably a few sequencing cores or a few places with sequencing equipment that I don't know about on campus. Oh, and there's a microbiomics core. So if you're doing microbiomics, there's actually a core that just does sequencing for you. Yeah, can't forget those guys. I work with them a lot. All right, so QSeq format. QSeq, you have all your data for one read on one line. That's kind of QSeq's thing. That's pretty much how you can tell you're looking at a QSeq file, along with the fact that the file will frequently say QSeq in the name. So each line, as you can see here, has basically just a crap ton of data on it. Some things you can probably guess what they are. Who can see what this is? What? Yeah, it's a bunch of strings of A, T, G, and C. That's probably your DNA sequence. In fact, just as a general rule, if you see something that's a long string of A's, T's, G's, and C's, you're probably looking at DNA sequence. Who here can guess what this is? Okay, yeah, nobody's going to guess what this is. I'm going to explain what this is in a little bit. It's actually very important, but it's not really designed to be easily human readable. Okay, so what do these things actually mean? So column 1 is the machine name, or the unique identifier for the sequencer. Basically, this is a unique identifier that Illumina gives their sequencers. Column 2 is run number. So this is the run number on that machine. This is where things get really entertaining with that core that really likes the QSeq format, because I think because they don't even actually stick to the official QSeq standard. So the run number is supposed to be an integer. This is actually data from them. As you probably noticed, this is not an integer. This is their own internal machine code plus an integer for a run number. So they like QSeq, but they actually give you your data back in what is not a valid QSeq format. Anybody who's tried to submit stem cell core data to ENCODE, where they're very strict about formatting, has found this out. Because if you try and transfer it over, they'll actually tell you that this is an invalid field for the run number. Let's see, column number 3. Column number 3 is the lane number. So I think generally sequencing flow cells have 8 lanes in them. I don't think they've gone above that. Tile number. Basically, it's going to be a positive integer. It's sort of information about the position within the flow cell. The exact X and Y coordinates are the spot that was being read. So the exact position in the flow cell of the read. 7 is index number. So index is going to be like the barcode number. Read number, it'll either be 1 or 2. So paired N1 or paired N2. So this is paired N2 reads. 9 is going to be sequence. It's that block of A's, T's, G's, and C's. 10 is your quality score, or your quality string. Can anybody tell me something that might be sort of interesting about this versus this? Do you notice any similarities between them? Yeah. The length of this string of text will always be the same as it's made over here. And that's because each letter here corresponds to a letter here, 1 for 1. And then, and then filter value. So this is basically asking, did it pass Illumina filtering? If it gets a 1, Illumina thought the read was of sufficient quality. If it gets a 0, Illumina thought the read was not of good quality. And some people think it's too stringent and do their own quality metrics. Other people, if it didn't pass Illumina metrics, will throw it out. Oh, yeah, FastQC. All right, FastQC is the format people will generally get their reads in. If you get your reads in QSeq format, what's going to be the first thing you want to do with them? convert it to FastQ. So FastQ, I think basically FastQ won the war because FastQ is a lot more pleasant to look at if you're a human. So FastQ says I'm not going to do 1 line per read. I'm going to do 4 lines per read. One of those lines is actually going to be a divider also. So one of those lines doesn't really have anything on it. Anybody here ever do any like printed material design or web design or anything like that? Or like user interface or anything? No? Okay. Well, one thing they always talk about is having white space. And if you have a document that's completely just a big block of text, people find that actually kind of makes them nervous or it makes them uncomfortable. So I think one of the reasons this won out is this has a lot more white space and the lines are a lot more manageable. So here you're going to still have a first line. It's going to start with an @ symbol, and it's going to be basically a bunch of this sort of code-looking stuff. And this turns out to be equivalent to QSeq columns 1 through 8 plus 11. So all that housekeeping data about how the sequence was read, where it was read, all that other stuff is on 1 line. That's segregated away from the DNA sequence. So here you can see there's just DNA sequence on this line. There's this plus, which you'll generally have a plus, and you may have a little bit of information on there, but usually nothing's supposed to be there that's important. And then below that, you have this long string of text. That's your quality string. So same data, different format. Who here thinks that this is more pleasant to look at than the FastQ data, or than the QSeq data? Who here doesn't really have an opinion yet? After you look at a lot of these, you'll start realizing that QSeq is a lot more pleasant to look at if you're human. So again, most aligners and most other programs assume you have FastQ format. So if you have QSeq format, you have to convert. All right, I used to walk people through doing, so I talked about multiplexing yesterday. Demultiplexing is the process of taking those reads from, say, these 3 samples, looking at those barcode sequences, and splitting them back into their original sample. So basically just taking a file that has all the reads and generating 3 new files from it that have the separated reads. So 1 for each sample. Demultiplexing, there's a few different computer programs that will do demultiplexing for you. I'm not actually going to have anybody run through this process for the simple reason that almost nobody does their own demultiplexing. And if your lab is doing your own demultiplexing, chances are you have your own pipeline for it already. So nobody I found was actually running this themselves anymore. A few years ago, people were running it a lot more. And the people who are running it, their labs tend to have pipelines for it. If you find yourself having to do your own demultiplexing and you don't have a way of doing it, shoot me an email. I can get you some resources to get it done quickly. All right, and then conversion of QSeq to FastQ. So as I mentioned, so the only thing you'll probably want to do before you convert your QSeqs to FastQ, if you get them, is you might want to demultiplex them. But again, most people are generally not having to deal with this anymore. If you do need to do this yourself, let me know. I can give you some resources for it. But chances are you will probably not have to do it unless you go through that 1 core. So there's a program that will convert QSeq to FastQ. Pretty much does it automatically. You don't even have to tell it what to do. You just have to tell it what directory to work in. And again, I'm not going to have people deal with that themselves because I found that almost nobody actually has to do it manually. The part that I am going to have people start doing is, so we've gotten the raw reads. So on our pipeline, we've gotten back raw reads. We've done our sequencing. We've had our library prepped. We've presumably gone over the experiment in great detail to make sure it's well designed. So now I'm going to talk about read quality, because this is something that no matter what format of data you're dealing with, no matter how you get your data back, you want to know if your data is good quality. What time is it? All right, actually it's 10:49. So this is a good opportunity. 10-minute break, everybody be back at 11 o'clock, and I'll pick up talking about quality scoring. And we'll actually do quality scoring and clean up on our reads, and then that'll be the end of the day. And I'm going to stick around here if anybody has any questions. Mm-hmm. Mm-hmm. Yeah. I don't know a good program to analyze alternative splicing, although I wouldn't be surprised if there is one. What lab was that? There's a lab on campus that I think might have been working on a program for that. And I don't remember the name of it, but I can try and find out. I would really appreciate that. Mm-hmm. Yeah, I know there was a lab on campus that was working on something related to that. Mm-hmm. Oh, okay. Yeah. Is your antibody from Santa Cruz? No. Okay. We've tested a bunch of different antibodies. We've finally found one that's secondary, 2 years back. Okay. Have you checked Ensemble just to see if there's known? There are some known mm-hmm. But I guess they're somewhat close to the size that I'm seeing, but it's not exactly. So I don't know if it's and then based on that, maybe there's a possibility that it's splice, mm-hmm. But I still don't know, and wanted something a little more. So in your case, I would actually say the best thing to do is actually save the Illumina data for later, and try and run it in PacBio. Are you familiar with that? Okay, so PacBio or Nanopore or yeah, I mean basically that's the two names people usually call it, is PacBio or Nanopore. Has a disadvantage that it has a bad error rate per base. So if you're looking for... Ooh, is that for the actual RNA? Yeah. Okay. But for what you're doing, it might actually even still be worth it to do because I think you can do a small scale run with PacBio, not super expensive. It might be worth it to see about just doing a quick run on PacBio with your RNA. PacBio has the advantage of getting reads that are thousands of bases long. Because in your case, it sounds like, are you able to say what gene you're working on? Yeah, it's like a methylase, but it's a super low. Oh, okay. Oh, okay. So it kind of makes sense that it would be. So PacBio can actually, I've seen reads of double that length from PacBio. So PacBio could actually read an mRNA from that thing from end to end. You'd have an error rate that would be not good for looking for single nucleotide variants. But if you're looking for splice variants, then you'd still be able to align it, and you'd still be able to see exactly what you're getting. You'd be able to say this. You'd be able to basically have RNAs that are read from end to end. Yeah, and it actually might make for better data because you might have splice variants that just aren't even completely described, especially in a gene that long. You can get some weird splicing stuff. Right. That's what I'm hoping. So especially if you're looking for splice variants that nobody's described. Yeah. Honestly, I would see how much it costs to just do a quick run of PacBio, and see if I could just do a quick run of PacBio. Thank you so much. Mm-hmm. Yeah. Unfortunately, PacBio don't have a ton of experience handling their data, but it should be doable, and I think there's resources out there to help you get started. Mm-hmm. Yeah. PacBio, I think in your case, the solution isn't to try and do more with the data you have, is to try and get it. You're really going to do much better if you get data that you don't have. Right, exactly, yeah. I can still do other things. I learned a lot of stuff. Mm-hmm. Whatever. It's just, yeah, for that one specific thing. Also, submitting some of my data for that, these there's weird Hmm. Yeah, exactly. If you're, yeah, I mean, PacBio should have no problem getting reads on your RNAs that go like end to end. So yeah, yeah, I think the knowledge you're going to gain from doing that should justify the cost. Because yeah, I mean, if you really want to see what's there in terms of RNAs, and you really want to say like, you know, you want to be able to say which exons are present from all the way from one to the end on a single RNA strand, you need PacBio. Mhm. Yeah, no problem. All right, it's 11 o'clock. I think we can probably pick it back up again. All right, so I'm going to start this off by saying a line I said before. I had a problem. I decided to go with a new format to fix the problem. Now I have two problems. Quality score is more like I had a problem. I somehow wound up with 5 different formats. Now that is the problem. Welcome to quality scoring. 5 different formatting schemes out there. Kind of annoying. The good news is, basically, you can actually boil it down into 2 different formats. And I'll show you how in a moment. So there's the Sanger standard, and Sanger is, again, the low throughput sequencing. And they came up with a Fred score. I'll go over what a Fred score means in a bit. The general rule of thumb for Fred scores is a Fred score of 0 means 0% confidence in the base call. A Fred score of 10 means 90% confidence in the base call. Fred score of 20 means 99% confidence in the base call. Fred score of 30, 99.9. Fred score of 40, 99.99. So Fred score of 40 is saying basically 1 in 10,000 chance that it was a bad call. Fred score of 30 is saying 1 in 1,000 chance. As for the numbers in between, you can kind of guess where they fall. But I generally go by sort of just the guideline of the 10s. That's the easiest way when I'm eyeballing it to know what they're talking about. So Sanger sequencing, these are the valid letters for it. An exclamation equals 33. A capital I equals 73. Anybody know where this standard comes from of coding numbers to letters? ASCII. Who got that one? Oh, okay. Just curious, did you get it from seeing The Martian, or you knew it beforehand? What? Oh, okay. Did you study comp sci? Oh, okay, nice. Yeah, a lot of people now don't really know ASCII, in part because now they're going with like these crazy UTF standards for things like encoding emojis. But ASCII was the original standard. So computers don't do letters, and computers don't really do text. Computers do numbers. And that gets awkward for a computer when it has to handle a text file. So imagine how annoying it would be if Apple decided that on their systems, capital A is going to be 1, lowercase a is going to be 2, capital B is going to be 3, lowercase b is going to be 4. And then meanwhile, Windows decided that on their systems, the exclamation point is going to be 33. They're going to have a whole bunch of these punctuation type characters, and then they're going to have the numbers, and then they're going to have more punctuation, and then they're going to have the @ symbol, and then capital A is going to be 65, and it's going to go through all the capital letters, and then there's going to be more punctuation, and then they're going to have all the lowercase letters, and then more punctuation. This would mean that you'd basically have completely different text on a Mac than you would on a PC, and maybe even different text on a Linux machine. This would be annoying as hell. The good news is all the computer manufacturers came together and pretty much decided on a standard for text. And they said an exclamation point is going to be 33. We're going to have the capital letters here. We're going to have the lowercase letters here. There's actually a reason for that, but you have to understand how these things are encoded in binary for it to make sense. But if you see how they're encoded in binary, it suddenly makes a whole lot of sense. There's also a bunch of, so 33 is the first printing character. All the characters before the 33 are what we call non-printing characters. Non-printing characters are things like a white space, a tab, a carriage return, a new line, a beep. And yes, beep is actually a character in ASCII. So the the Sanger standard decided to start with the first printing character. Solexa, for reasons I don't exactly recall, said they want to start with character number 64, the @ symbol. So Sanger is base 33, Solexa is base 64. Illumina initially decided they wanted to go kind of with the Solexa standard, but not exactly with the Solexa standard. So Solexa said they want to do -5 over to 40. Illumina said they just want to do 0 to 40. Basically, Solexa says we'll have negative Phred scores. I'm not exactly sure what a negative Phred score means beyond the fact that the machine, basically a Phred score of 0 means the machine has no confidence in the read. A negative Phred score, I think the machine has even less confidence in the read. Illumina decided to keep things a little bit simpler and kind of say, you know what, a crappy read is a crappy read. And once the machine says it has no confidence in the read, it's not really worth saying how much no confidence it has. So the difference here is mostly in terms of ranges. And then finally, when Illumina went to version 1.8, they said, oh, you know what? We actually think that the Sanger format is better. We're going to go with base 33. And part of that was because everybody else at that point was using base 33 too. So base 33 is pretty much the standard for quality score strings. If you, for some reason, get back your quality score data as base 64, you'll also want to convert it back to base 33. That's just kind of an easier standard to follow. You can figure this out by hand. There's a couple different tricks. You can look at the different characters that are in use. So for example, looking at this one, you see there's a question mark here. Question mark is valid for Solexa. It's not valid for a couple of these other ones. You also have an @ symbol. An easier way of doing this, honestly, is either look for positions where you have an N, so you have an uncalled base, or look towards the very end of your reads where the quality seems to be falling off. See what the quality score letters are there. And if those letters fall sort of towards here, you're probably looking at base 64. If the letters fall towards here, you're probably looking at base 33. In fact, ideally, you want to find like an uncalled base, which will be denoted by either an N or a dot. If you find one of those, look and see what the quality score is. An uncalled base is going to have a very low quality score, guaranteed. And you should be able to say, okay, that one has an @ symbol. An @ symbol is a pretty respectable quality score in base 33, but you shouldn't have a respectable quality score on an uncalled base. So that must be a very low quality score. That would be base 64. And then obviously if you have an exclamation point, that's not even a valid character if you're doing base 64. So that tells you right off the bat. I'm not going to have anybody do these by hand because it turns out that the program I'm going to have you run will just tell you what your quality score scheme is. So quality score is important. A lot of different analyses need to know this. And a lot of programs, you either have to, it'll either assume a certain encoding or it'll make you tell it the coding explicitly. Generally, if a program is going to assume a coding scheme, it's going to assume that it's base 33. And a lot of programs, if you don't explicitly tell it an encoding scheme, it'll just go with base 33. General rule is if you get base 64 data again, make it base 33. So a few different programs to do this. There's, again, make sure, if you're dealing with sequencing files, if for some reason you find yourself getting sequencing data from multiple cores and they're giving you back quality scores in multiple formats, get it all to one format. And also get yourself using one core because that way it'll be more consistent. All right, so the program we're going to use to look at the quality of our reads, and there's a couple sets of reads in your Workshop 2 data to deal with. We're going to use a program called FastQC. Did anybody take a look through the programs that I supplied? No? Okay, so I supplied you programs called Sickle and Scythe. I did not supply you with a program called FastQC. So how are we going to get a copy of FastQC? Download it. That's the exact answer I was looking for. Where are we going to download it from? What's that? Sorry, I can't understand what you're saying. Okay, some kind of repository. Well, we're going to download it from somewhere on the internet. How are we going to figure out where we want to download it from? I heard it somewhere over there. Google. Chances are if I ask you how to figure out something or how to find something, Google is always a valid answer. And actually, Google in this case is the right answer. So everybody's going to pop open a web browser really quick. So open up Chrome, open up Firefox, open up Safari, open up Microsoft Internet Explorer if you have really bad judgment. And again, we want to do a program called FastQC. So FASTQC. What's the Google search term that we can probably use to find this thing? FastQC. So, and people say bioinformatics is hard. Truth be told, learning how to Google things efficiently in bioinformatics is hard. And then once you learn that, bioinformatics becomes easy. All right, so everybody should see probably one of the first link or two is going to be to a site called baberham.co.uk. So that's actually where you want to go. Baberham is the institution that hosts FastQC. And you should see a download link for FastQC. We're not going to download it to our own personal computers, though. So does everybody see a link to download FastQC? And then you should have the option to download it for either. One option should be to download a version for Windows or Linux, and another option should be to download a version for Mac. Was anybody not able to find that? Yes? Oh, click on the download button. So yeah, if you just get a thing saying download, that'll take you to the downloads page. When you go to the downloads page, you should see a Windows Linux version and a Mac version. Do you see that now? Okay. Was anybody unable to find it? Let me see what you got. You might have clicked a slightly different link. Okay, so that's definitely the right page. Click on download now. Oh yeah, so if you look at the top, there's FastQC. And then you see there's FastQC 0.11.8 Win Linux and 0.11.8 Mac. So regardless of what kind of computer you're on right now, what kind of system are we going to be running FastQC on? We'll be running on Linux. So we all want the Windows Linux version. Again, we're not going to download this directly to our computer. So pretty much whatever browser you're using, you should be able to right-click or maybe control-click depending on your system, but you should be able to right-click or control-click on the link. And you should have the option to copy the link. So we're actually going to copy that link location. Okay, so did everybody get the link copied to their clipboard? Awesome. All right, so in our SSH session, we're going to change directories and we're going to CD into WS2. So oh wait, actually we didn't untar. So the first thing we're going to do, and I'll put the commands up here again. Actually, let me make this even easier. We're going to do that command. So we're going to cd into our Scratch folder. And if you do ls in your Scratch folder, you should see that you just have one file in there, unless you already have other stuff. But if you just copy this over and you're new to the Hoffman cluster, you should have just my one file in there. We'll run this command on it, tar, and then -xvf, and then ws2.tar.gz, and those will all be those will be separated by a space. Once you run that, you'll get something that I nicknamed terminal diarrhea, which is you have text flying across your terminal faster than you can read it. And there'll be a lot of it. Are people seeing that? Okay, that's actually a good thing. That means it's running. So that's, yes? Sure. Are you getting an error message? Can you read your error message out loud? Yes. So can you read me your command prompt? Or more specifically, does your command prompt end with a tilde? Does it end with a little squiggle character? You're still what? Oh, okay. Yeah. Let me make sure you didn't get your connection dropped. Oh, okay. I'm betting that you're not on the Collaboratory Wi-Fi. You are definitely. That's what happens with it. All right, put in your password. Here we go. Okay. Yeah. It's running a little bit slowly right now, but you're gonna. There it goes. Yeah, it's gonna start generating text faster than you can read it. Yep, no problem. So before you do that, let me just check this real quick. So you're gonna actually lose your connection again soon. Okay, so you want to make sure you're on Collaboratory AP.
So should I log in?
Yeah, it's. Okay, yeah, let it. Your connection's gonna die. Give it a minute, and then log it in again, and then you should be able to run. Yeah. So just a reminder, if you find that you're losing your SSH connection to the cluster, sorry, double check that you're on Collaboratory AP. If your connection to the cluster drops, there's a good chance that you're not on Collaboratory AP. There's in fact a good chance that you're probably on one of the UCLA networks, and the UCLA networks in this room will randomly drop your connection. They do fine for internet browsing, honestly, because they'll like drop intermittently, but where you need a constant solid connection, like for an SSH to the cluster, they'll just randomly drop and you'll suddenly find yourself without a connection. All right, so I think people have had a chance to run this. Wei Guang, have you gotten your... Okay, you're logged in? And then did you get QRSH going? Yeah, QRSH again. And then it'll take about a minute to get the to get your interactive session going. So let me know when you got your interactive session going and I'll get you caught up. Okay, you got your interactive session? Okay, let me go over there and just make sure you're caught up. Okay, that's running now. All right, the untarring process should take about a minute or two to complete. And once it's complete, if you type ls to see what's in the folder you're in, you should see a new folder called WS2. Everybody see that? How do we get into that folder? CD. So let's CD into WS2. All right. Since we're in a new folder, what do we probably want to do? What? See what's there? See what's there. How do we see what's there? LS. Can somebody tell me what they see? Yeah, so as I mentioned, this course is a combination of different courses. We're only going to be using the Workshop 2 data folder. I kept Workshop 4 data in there because some people may want to have a little extra data to mess around with on their own that we haven't touched. So there's actually 2 full sets of data in the Workshop 2 data folder. And in the Workshop 4 folder, there's several sets of data as well. So we're going to CD into Workshop 2 _ data. All right, and then in our Workshop 2 _ data folder, we're going to type the command wget and then space, and then we're going to paste in that URL we just got. So if you're on a Mac, you're going to paste in the URL by doing Command V. And if you're on a PC using PuTTY, you should be able to paste it just by right-clicking in the terminal. Is it working? So yeah, you're basically, so rather than have to go with a connection through your computer, you're directly downloading the program to your folder on the cluster. Yes? How do you paste? Is that what you're asking, or? Oh, you're going to CD into the workshop to, oh, wget. Is that what you're asking about? Okay, yeah. Wget is a program that will download URLs to your folder. I don't know if W is even a valid command. Interesting. Huh, okay.
I mean, there's no file when I look in CyberDuck.
Yeah, it's definitely not downloading anything. Okay, it's probably giving you data on a user, but yeah, there you go. It's, yeah, I just started up for you. So actually you want to get, you want the Win Linux version, because you're going to run it on a Linux machine. So.
How did you do that? How did you do the last?
Oh, if you click with 2 fingers, that's equivalent to a right click. So copy link address, and then it's going to be, so let's see, wget, and then command V. Yep. Yes? Oh, so Control V doesn't work on PuTTY. Oh. The thing that usually gets PuTTY to do its thing is.
Oh, I'm sorry.
Oh, okay.
I have a mouse there.
Oh, yeah. There you go. If you right click, it'll paste it.
Oh, okay.
So hit enter and you should get started.
All right, thanks.
All right. Did everybody get the download going? Was anybody unable to get the download started? Okay, good. That means, so this is occasionally where I start finding out that people are on compute nodes that don't have internet connections. Fortunately, I think they fixed that. Okay, so currently you're in your Workshop 2 data folder, and you've just downloaded a copy of FastQC. So if you hit LS, you should see that there's something in there called FastQC, and then some version number, and then .zip. So we have a .zip file. What are we probably going to need to do with it to start working with it? Unzip it. What's the command to unzip it? Unzip. Did you download a DMG? Then you clicked actually on the link for the Mac version. So actually, it's even easier than going back to the page. Let me get over to your computer for a second. So you're just going to have that extra file in there. Yeah, the DMG can't be unzipped.
Oh, nice. So point.
Cool. Yeah, so you can ignore the DMG file. It's going to be there, but it's just junk. Okay, yeah, so if you noticed you have a .dmg file instead of a .zip, you accidentally copied the link for the Mac version. The good news is this is really easy to fix. So 2 important things I'm going to teach about the command line. These are probably the 2 most useful things I will tell you the entire class for working on the command line. Tab autocompletion. Anybody familiar with that? Okay, a few people. Tab autocompletion does not make you lazy. Tab autocompletion makes you smart. Anytime you're trying to type in a file name, start typing it and hit Tab. You should be able to autocomplete the file name. If you can't autocomplete it in most circumstances, that means you probably have an error in the file name or the file isn't where you think it is. So tab autocompletion is actually really nice, even if it's a short file name, because tab autocompletion doesn't make typos. It actually prevents a lot of typos. So try and use tab autocompletion as much as you can. The other thing is the up arrow on the command line. Does anybody know what that does? It pulls up previous commands. So if you hit the up arrow once, you get your last command. If you hit it a couple times, you'll start just pulling up commands before that. So it basically goes through your command history. If you accidentally downloaded the Mac version, which ends in .dmg, all you have to do to correct that is hit the up arrow until you see your wget command again, backspace over the .dmg in the link, and change it to .zip. And then rerun it, and you'll download the .zip file. So you should have a .zip file. Once you have the .zip file, all you'll really need to do is just type unzip and then the file name. And when you type unzip in the file name and hit enter, and by the way, this is a really good case to use the tab autocomplete, so you don't have to worry about typing out the version number yourself. If you just type in fast and hit tab, it'll probably autocomplete with the whole thing for you. You might be the exception to that because you'll have to choose between the .zip and the .dmg. So if you tab autocomplete, it'll take you as far as it can, and then if you hit Z, it'll take you the rest of the way. All right, once you hit that, you'll get another brief case of the terminal diarrhea, where it's just telling you what it's unzipping. And then you'll get your command prompt back. And at this point, you have a working copy of FastQC. All right, so now's the part where I walk you guys into a bunch of errors so that you can see some errors you get when you try and run this thing. So if we look in Workshop 2 data, we're going to notice that we have now a folder called FastQC, starting with a capital F. So let's CD into that. Once we get into it, since it's a new folder, we're going to ls, and we should see a list of all the stuff in that folder. And we'll notice that we have a file here just called FastQC. That's probably our executable file. So let's try and run it by typing /fastqc. Hint: you are probably going to get thrown an error. You should be in the FastQC directory. The command to run FastQC, /fastqc. Oh, a regular slash, a /. Yes, FastQC was lowercase. You should even be able to tab autocomplete that. No spaces. Okay, so everybody should be seeing a permission denied error on that. Anybody know why that is? Yeah? Yeah, so in Linux, permissions work. You basically have groups of permissions. So if you run ls-l, you'll get more detailed information on the files. This block over here is permissions. This is the file owner. This is the group. This is the size of the file, although not in any easily human readable format. Dates when they were last handled, that kind of thing. So if you look at the permissions, you'll see that there's the first letter, and the first letter will say D if it's a directory. It may say some other things, but primarily you're just going to see D telling you it's a directory. you'll then see 9 other spots. And those 9 other spots are 3 groups of 3 permissions. And those permissions go RWX, read, write, and execute. And in terms of 3 groups, it's me, my group, and the world. So here we go. So here we see R, W, and blank, and then R blank blank and R blank blank. So this one, I have permission to read and write. I don't have permission to execute. My group has permission to read. Everybody else in the world has permission to read. So we need to actually give fastqc permission to be executed by us. Anybody remember the command to change permissions? Okay, heard somebody say chmod. The command is chmod, and we're just going to do chmod plus x, so we're adding execution permissions to fastqc. So chmod plus x fastqc. And if you hit enter and nothing happens, that means it probably worked. Okay, so the next step is where you can actually just hit the up arrow probably 2 or 3 times, and you should get back this command for /fastqc. We're going to try and run it again. It's going to throw you an error, but it's going to throw you a different error this time. So this time the error we're probably going to get is something called a headless exception, which would make a really good horror movie title. All right, so in this case, I'm just going to tell you that what the headless exception means is we're running on a computer right now that doesn't have a graphical interface on it. So the Hoffman node you're running on doesn't have a graphical connection to you. FastQC was designed to run one of 2 ways. If you run it without any file to point it at, it's going to try and open up basically a graphical session where the user interacts directly with it, tells it to load files and look at data and that kind of thing. Since we don't have a graphical connection driver with the cluster, it doesn't have that, so it's going to throw an error message. So we can run it in its other mode, which is where we just tell it a file to work on. So yeah, okay, so we're gonna rerun it, and we're gonna still do /fastqc, but now we're gonna give it a file to work on, and that file is gonna be /human001 underscore pe1.fastq. So what does the ... mean? Up a level. So we're saying go up a level, look in that folder for this file called human001 underscore pe1.fastq, and basically run fastq on that file. When you run that, you'll start seeing stuff that looks like this pop up on your screen that just tells you approximately how far complete the analysis is. That's probably going to take a good 2 minutes to run, maybe 1. It should autocomplete part of it, but you have a bunch of different files with similar names. So you might tab autocomplete, it'll fill in part of the name. You type the next letter, and then tab autocomplete again, it'll fill in more of the name. Then there's a good chance that you're either in the wrong folder or you have a typo. Let me have a quick look. Oh, I see what the problem is. Yeah, you had an underscore instead of a dot. So just a little typo.
And then why did you put this dot?
So dot slash means in this folder, it's basically pointing it directly to the folder you're in and telling it to run a file in there. And yeah, it ran through really quickly. So that's where things get a little bit complicated dealing with Linux. It looks for files to execute in something that's set in your command called your path. So if you actually type on your command line echo space $, and then path in all capital letters, it'll tell you exactly where it's looking for files to execute. Your fastqc folder is not on your path. So even if you're actually in that folder and you type the file name, it's not going to look there for files to execute. But if you actually give it an absolute file, if you give it sort of an absolute pointer, which in this case you can do just with the dot, because you're saying this folder / fastqc, then it's going to try and run that file. All right, once you've done that, yeah, we're okay. Once you've done that, you're going to do cd ... So you're going to go up a level, and then you're going to type ls. And you're going to notice that there's a file that wasn't there before. human001 underscore pe1 underscore fastqc.html. So there's an HTML file, and that file wasn't there before. So we just made that file by running fastqc. If you're trying to look at an HTML file, what's the best way to do that? Internet browser. That's what your internet browser was made for. The only thing is your internet browser is on your computer, and this is on the cluster. How are we going to get this from the cluster to your computer? CyberDuck. So open up you remember how we made that Scratch folder bookmark? Open up the Scratch folder bookmark, and then you should be able to click on WS2 and then workshop2 underscore data, and you should see the HTML file in there. If you don't see it and you think it should be there, hit the refresh button, because CyberDuck doesn't automatically refresh. Okay, and I hear the clicking in the room slowing down. So did everybody find that file? Was anybody unable to find that file or unable to connect? Okay, so really to just look at that file, just drag and drop it from CyberDuck into your desktop. Obviously, you can drag and drop it somewhere else if you want. Desktop is usually just a convenient place. I don't think you can put it straight into your browser. So yeah, put it on your desktop and then just double click it. It should open in your browser. So it should open in your browser. Is there anybody here who is unfamiliar with how to use an internet browser? Because I will hit you over the head with a tack hammer if you answer yes. Okay, good. I have yet to see anybody say that they are unfamiliar with a browser yet, and they weren't trying to troll me. All right, so if we look at our internet browser, we can already see a couple of things that are useful. So there's a basic statistics window up here. That's telling us our file name. That's telling us our file type, which is just conventional base calls. Encoding, Sanger / Illumina 1.9. What question does that answer for us? What's our quality score encoding scheme? So yeah, that's one of the reasons why I don't have anybody do it by hand anymore. You should pretty much always run fastqc when you get sequencing back. Most of the time, it's going to be boring. This is one of these things where I keep saying, make sure the boring stuff is boring. FastQC should generally be boring. If you get back a FastQC report and it's interesting, start to worry. I've gotten back some FastQC reports that were actually very interesting, and it turns out the experiment was crap. Basically, FastQC said that it was very good quality reads, but it also, when it was reporting on repeated sequence, said every single sequence starts with the same 200 bases, which was unexpected, and turns out it's because somebody misdesigned a primer. They were trying to sequence plasmid, and they designed the primer very badly, and every sequence started with the same 200 bases because it turns out they were sequencing their backbone. Anybody who works with plasmid can kind of understand that's somewhat ridiculous. Or not ridiculous, but it's kind of useless. So again, make sure the boring stuff is boring. Especially look for things where you have a red X. So FastQC will generally throw a red X at you if something is potentially concerning. And in this case, it threw up a red X on us for per base sequence quality. So a couple options. Oh. All right, so Joanna just hit with a question asking about which folder. So let me just go back here so I can actually see it. Okay, so the answer for Joanna is you are not copying a folder. You are actually copying, you're going to your workshop2_data folder in the class file, and you're going to copy over just the HTML, the file ending in .html. So it's going to be human001_PE1, and then I think it'll be fastqc.html. But you want the file that ends in .html. Okay, and she's happy now. All right, so a couple of options here. Giving up is always an option, but generally not one that your PI will be cool with. Or take the advice of the cat and start cleaning. All right, so where we are, we've checked the quality of our raw reads. We weren't particularly happy with them. We saw that there was an alert thrown on bad quality read. So we're going to do like the cat, we're going to do some cleaning. This is a paper you can look at. It talks about some common issues that show up in next generation sequencing. There's actually probably a lot more papers now on this. This is sort of an oldie but goodie. All right, so there's two kinds of garbage we're going to be dealing with here. And I think what I'm going to do is I'm going to walk through what we're going to be starting with tomorrow, which is going to be the trimming and the adapter removal. So who here remembers what an adapter is and what it's for? Go for it. So that's one of the things that the adapter does. So the adapter, once you've made your DNA fragments from your library, you'll stick adapters on either end of the fragment. And then the adapters are going to have sequences on them that'll help with things like priming, things like identifying the source, which is your barcode. They'll help with binding it to the flow cell, and that's what you were talking about with the oligos for binding. They have, and any other basically anything else that your sequencing platform needs to be on the ends of your sequence to read. So something that can happen is these adapters all have priming sites, and if you prime and read all the way through your fragment, you'll read into your other end primer, or you'll read into your other end adapter. Should your adapter sequence align anywhere in the genome you're interested in? Okay, I'm seeing at least a few people shaking their heads. If Illumina designs an adapter sequence that matches part of the human genome, a lot of people are going to be really upset. And honestly, it would be Illumina's fault. Adapter sequences are generally designed to not collide with known genomic sequence. So adapter sequence is basically artifact. It's sequence that's there but doesn't belong. It's essentially garbage once it's been used. So we want to get rid of adapter sequence. Okay, so it appears that unfortunately my batteries decided to take lunch a little bit before I decided to take lunch. So for the rest of the slides, I'm actually going to overdub them. So that's why my sound sounds a little bit different now. So going back, I was talking about why adapter sequence is garbage, which it pretty much is. You don't want adapter sequence going in for sequencing. You also don't want low quality sequence going in for sequence analysis. Feeding low quality sequence into things like your aligner or into things like your variant calling. The good news is most of these programs are quality score aware, and they're pretty good about identifying when a region of sequence is just garbage and throwing it out. The problem is they still have to do some analysis on the region to at least determine that it is in fact garbage. This ends up wasting time, so at the very best, you're going to waste time throwing out garbage that you just keep throwing out at every step. And at the worst, this could actually end up causing some amount of confusion when it comes down to doing your sequence analysis down the line. So when it comes to trimming, there's fundamentally two options out there for how a program can trim. There's hard trimming, or what I call smart trimming. Hard trimming removes a certain number of base reads, or I should say it removes after a certain number of base reads generally. Smart trimming looks at the quality scores. The general idea for a hard trim is, let's say that I know I only need about 50 bases, and I know that generally the first 50 bases in a read are good. I can run a hard trim and just trim every read down to 50 bases. The alternative is smart trimming, or quality score aware trimming. This is going to go through the read, and it's going to analyze segments of the quality scores, and it's going to look for where the average quality score in a region drops below the threshold. So why would we pick one over the other? It turns out that hard trimming is a fairly simple algorithm. Find the 50th base and get rid of everything after it. Simple, fast, and it turns out that's its advantage. It's very simple and very fast. If you're doing a protocol like RNA-seq, where you're trying to attribute different fragments back to their mRNA and just count the number of transcripts to get an idea about gene expression, 50 bases is usually a pretty good amount to attribute a transcript. So hard trimming is a very efficient option there, and it's not going to cost you too much in terms of data. If you're trying to do variant discovery or find structural changes or other rare things, you probably want to do smart trimming. Smart trimming is going to try and keep in as much sequence as possible and just cut off the sequence where the quality starts to fall off. So that's an advantage. The disadvantage of smart trimming is essentially it has to take a segment of the quality scores for each read, and it just keeps taking more and more segments until it finds a segment where the quality score has dropped too low. That's a lot of division operations. That's a lot of operations in general. So quality score aware trimming tends to be a whole lot slower. To do the trimming and to do the adapter removal, we're going to use two different programs, Scythe and Sickle. Both of these programs are already ready to be installed in your software in your Workshop 2 data folder. So Scythe gets rid of adapters, and it's what's called quality score aware. Scythe will find adapters, but it's willing to call an adapter even if there's a mismatched base, so long as that base is a low quality call. Sickle is a bad quality sequence remover. It trims off poor quality sequence. And since we know that it's quality score aware as it's listed here, that means Sickle is probably doing smart trimming, which it definitely is doing. So the ever important question, how did our run go? And as I mentioned before, the Phred scores tend to work as a log scale. So I tend to just go by the rule of tens. A Phred score of 0 means no confidence. A Phred score of 10 means a 1 in 10 chance of a wrong base call, or 90% confidence. Phred score of 20, 1 in 100% chance of error, or 99% confidence. Phred score of 30, 1 in 1,000 chance of error. Phred score of 40, 1 in 10,000, or 99.99% confident. Generally, for single base calls, you're not going to see the confidence scores go much above 40. Here we see two charts from two different FastQC runs. I think both of these may have actually even been the same run, or not the same run, but the same sequencing data. But the one on the left is after trimming, the one on the right is before trimming. So on the x-axis of each graph, we have a position and a read. On the y-axis of each graph, we have a quality score. And again, it's Fred format, so it's logarithmic. If you look at the graph on the left, you'll see that everything is staying well above a Fred score of 30. So for these ones, we are well over 99.9% confident that the right base was called in all of these. If you look at the chart on the right, we can see that towards the ends of some of these reads, there's extremely low quality data. Some of these things have completely uncallable bases at the end, or bases where the confidence is less than 50%. So one of our goals is to get rid of these. These are, again, effectively garbage. They're either going to be ignored at best, or they're going to mess with results at the worst. So we want to clean these out, and that's what trimming does. And I believe this is actually where I ended class for the day, so we're going to pick up again with this tomorrow.